What is deep learning? And what are some of the benefits of deep learning over other AI technologies? These are the questions that we'll try to answer in this video. For starters, deep learning is one particular class of machine learning models that has proven itself to be extraordinarily successful in recent years, especially in the domains of computer vision and natural language processing. In this video, we'll be covering the three main benefits of deep learning. And to do that, we'll be using the CV and job matching machine learning model, benefit number one of deep learning. The first benefit is related to the training of machine learning models. And to understand that benefit, we need to compare it to traditional machine learning models. So in traditional machine learning models, as you start to add more and more training data, at a certain point, the traditional machine learning model will stop being able to learn from that additional training data. For example, in the CV and job matching machine learning model, as you're showing the machine learning model more and more examples of matching job and CV pairs, at a certain point, those additional examples stop teaching the model something new. And the reason for that is that traditional machine learning models have a limited capacity to learn. The underlying reason for that is that traditional machine learning models have a limited amount of parameters or degrees of freedom to be able to absorb all of the information in the examples that you're showing the model. Even worse, the algorithms that are used to train those traditional machine learning models, they stop working at a certain amount of examples, so they just start failing. You can't train traditional machine learning models on, let's say, 100 million examples or more at a time. The reason for that is that those algorithms were designed to work in a batch mode, allowing you to train on all examples simultaneously. Deep learning addresses both of these issues. First of all, in deep learning, if you have more training data, you can simply scale up the amount of parameters or degrees of freedom in the machine learning model. So you can basically scale the model indefinitely as your training data grows. Secondly, the algorithms used to train deep learning models are mini-batch algorithms that show the deep learning model a mini-batch of about 100 examples at a time to the model. And in that way, the deep learning model can learn from small batches of examples at a time, and you can repeat that process indefinitely, even for huge amounts of training data. Benefit number two, deep learning allows you to extract complex outputs out of the machine learning model. Traditional machine learning models are limited in the types of outputs that they can provide. They could, for example, make predictions of a quantity or make predictions of probabilities of something happening or not. Or, for example, try to assign labels or classes to items. But if you're looking for more complex outputs, such as being able to translate, for example, a vacancy from one language to another, or being able to generate a caption for an image, or, for example, being able to match CVs and jobs together, you might want to look at deep learning because of the more complex outputs that it can provide. For example, in the case of CV and job matching, the output of the deep learning model might not be recommendations themselves, but might be so-called embeddings, which are useful representations of the CVs and of the jobs that enable you to build downstream applications such as a recommender system that recommends the best CVs to a job or vice versa, the best jobs to a CV. Benefit number three is that not only can you extract complex outputs out of deep learning models, but you can also feed them with complex inputs. For example, if you're trying to train a machine learning model to match candidate CVs and job vacancies, those CVs are likely to contain a section on work experience. Now, in traditional machine learning models, you wouldn't be able to feed that work experience section to the traditional machine learning model. Instead, the machine learning engineer would have to summarize that work experience section into a fixed number of properties of numbers that summarize that work experience. For example, the machine learning engineer might decide to compute the average number of years that the candidate has worked in each position, or maybe the total number of years that the candidate has worked. Those would be two fixed numbers that the traditional machine learning model may receive. In deep learning, however, the deep learning model can receive the work experience section as it is represented in the data. A deep learning model can read the individual positions on the work experience section. And because of that, the deep learning model has access to more information and can make its own summary and its own decisions about what is relevant and what is not relevant for the particular task at hand. And that opens the door to improved models, better accuracy, and a better quality model overall. That concludes the 3 main benefits of deep learning over traditional machine learning models. If you're interested to find out more about the different types of machine learning models and what they could mean for you, I invite you to go and please check out our website, radix.ai.